Hey guys, welcome to the next video. In this video, we are talking about roadmap to machine learning. So if you are interested in machine learning, this video will help you to figure out the pathway using which you can start working in machine learning. But first, let's figure out what machine learning is. A basic definition is the machine learning is the study of computer algorithms that improve automatically through experience. It is the study of getting computers to act without being explicitly programmed. What are the examples of machine learning? We all are using apps like Facebook, Twitter, Gmail. Apps like Facebook and Twitter, they are using the comments, like your uploads to recommend the post to you, to figure out the sentiment analysis on the tweets, on the comments. Then we have apps like Google Translator, where it's translating one language to another. Then we have self-driving cars, where you are just sitting in a car, you are not driving it, but that car is being self-driven just because of the machine learning model in it. That machine learning model by itself is thinking whether to stop, whether to move on, in which direction to go, what should be the speed. So each of these decisions have been made by that machine learning model. So isn't it quite fascinating to use machine learning, and we should properly know the pathway to be a good machine learning engineer? But first, let's understand, does we really need machine learning to solve a problem? So let's take an example that you want to build a calculator. So would you be using a machine learning model in making a calculator? The simple answer could be no. Why? Because you can simply program that calculator. You have the logic to feed to your program. So problems where we have a human limitation, we can't mathematically code a logic, in those cases we require a machine learning model. The simple thing is to automate the task, right? So with this said, let's understand the pathway. So first of all, when we are working in machine learning, we need to collect data. Data is the most important thing when you're working on any project. So what you need to think about is what kind of problem we are solving. What data sources already exist? Is that a public data? And where should we store the data? Because if you're working on machine learning projects, then this data, you could have terabytes of data. So to store that data, you need an efficient plan. You need to figure out from where you will get those data and what is the credibility of data. Then comes the type of data. What type of data do we have? So first is structured data. Example for that could be nominal categorical data. Structured data are like where your data is properly in a proper format, like a CSV or a JSON or an XML file. And in that we have further types, like the data could be a nominal or a categorical data. For example, labels, male or female. Your data could be numerical data, where you have numbers like age, salary. Then you have ordinal data, where you have order in the data, but still they are in the categorical form, like reviews, 1 to 5 rating, or feelings, very sad, sad, happy, very happy. It's ordered, but still these are not in numerical form. Then the time series data. For example, if you are predicting the stock prices, then you need to have the data for previous months, previous years as well. So there we require time series data. Then comes unstructured data. Unstructured data is a kind of data where you don't have any fixed structure to a data. For example, images, videos, or text data. So there is no structure to your data and you need to treat your data first. Then comes a very important point, that is exploratory data analysis. When we are exploring our data, we first try to learn about the data we are dealing with. As you can see in this data, we are given these outputs, and what we have to predict the median house values. So when we are doing the data analysis, we first make sure that which inputs are really important for us to predict the median house value. And as you can see in this data, we have some missing values over here. So the next step is treating our data. So to treat our data, we need to follow the data processing path, where we prepare our data. For example, first we do feature imputation. We fill up the missing values in the data. As you can see in this example, I am having null values over here. So I have to treat this data. I can't feed this data to a machine learning model because there are some missing values. So I can fill this missing values with 0 or mean or any median value. Then comes feature encoding. For example, if in a label, let's say color label, you have data like green, red, blue. So you can't feed these labels to a machine learning model because your model can't understand this. It's a label. So you need to convert these labels to a numerical form. So we'll do the feature encoding over there. Then comes feature normalization or standardization. For example, if you look at this data, you have person's name, which you will treat with a categorical data, or let's say we don't want this name, this column. And then we have columns like salary, years of experience, and then we are predicting the position level of a person in a company. So we require these parameters, but let's assume if you are using Euclidean distance to calculate this, if you are applying any model, then the range of this salary parameter is in thousands, but this range of your experience is like 1 to 20 or to 30. The learning of your model can become biased because of different range values. It could think that salary is a more important parameter, but that's not the case. So to make our model unbiased, we standardize the data, and we have different standardization techniques. One is the standardization, normalization, right? Then comes the feature engineering. In feature engineering, we transform our data to a more useful form. For example, you can see in this data, we are given this categorical data, and once we have treated this categorical labels, we are converting it to a numerical form where I have these labels red, green, blue, and at whatever index I am getting red, it's 1 and others are 0. So I'm transforming my data, giving it a more meaningful form for my machine learning models to learn easily. Then comes the feature selection. As I've already told you, like if you are predicting house price, then you have to figure out which features are really important for me to predict the house value. For example, like if you are given features, then a feature like location would be important, or the age of the house would be important. What amenities I have closer to my house, that's important. And features like color of your house, the doorway of your house, that's not that important for me to predict the house price, right? So we need to figure out these most important features as well. Then comes data splitting. In data splitting, once we have our data, we have processed our data, we have done the data wrangling, data processing. After that, we perform the data splitting part, where we split our data to training, validation, and test data. So we are given a data. At the time when the model is learning, I will give a training data to my model, which will be 70 to 80% of the data I have. Then once I think that model has learned, I'll give it a validation set, where I will see that how my model is working, and I will do the hyperparameter tuning. After that, I will feed the test data to my model, based on which based on the learning my model has done on training and validation data, my model will predict for the test input data that you are giving, and I will compare it with the actual outputs I have. So this will indicate that how my model is going to perform in the real world scenario. After that, the machine learning process, we have to think about an algorithm which we'll be using to train on this data, right? So first choice is supervised algorithm. So first choice is supervised algorithm, where we are given a data which is completely labeled. So right, if you are given these images, your model knows that these are apples, and now your model will learn and will try to predict. In supervised learning algorithm, we have models like linear regression, logistic regression, k-nearest neighbor, support vector model, decision tree, and random forest, AdaBoost. In supervised, we can perform both regression as well as classification. Or neural nets, where we use deep learning models to predict. These data sets are labeled, and thus we call it as supervised, because we have the supervision, like what target we are predicting, that's given to us. Then comes unsupervised algorithms. The example for that could be clustering, dimensional reduction models, anomaly detection. In these data sets, you are given an input, but these inputs are not labeled. Like your model would understand that whether it's an apple or a banana, it would just know that it will just predict that these data sets or these data points are similar. So it will cluster your information, but it can't say that to which label it belongs to because we don't have any labels. So that's why it's called as unsupervised algorithms. After that, what we have is the analysis or evaluation. Once you have predicted something, you need to evaluate like how your model is working. So you are giving a test data to your models will make a prediction and you will compare those predictions with some actual test values. For that, you require evaluation metrics. So suppose if we are working on classification data where we are given defined data, in that case, we can use matrices like accuracy, precision, recall, F1 score. All these parameters we can use based on a confusion matrix. We can easily figure out that how my model is performing. And if that's a regression task, then we could have evaluation metrics like mean squared error. We could use mean absolute error, or we can use R squared error. There are multiple other regression matrices also. These are some of the examples, right? So guys, in this video we have learned like first you have to figure out whether you can deal with any problem using machine learning or not. After that, you figure out what data you require, where it would be present. Is it a public data? How you will work on that data? Then we look at the data, we do the exploratory data analysis, we figure out what we need, what will be the action and which parameters will be important. Then we do the data processing part where we do feature engineering, where we trade with encoding our data, where we deal with the selection of data, the input parameters. After that, we'll deal with the machine learning algorithms that we require, whether it will be supervised or unsupervised, and based on that, we figure out the evaluation metrics. So guys, that was all the basic steps that you need to know when you are working in a machine learning field.